Hello guys, this is day 47 of me posting every single day to become a software engineer. Sorry for not posting yesterday, it was a long day. Boot.dev is currently run out and I don't know what I'm going to do about it. I'm pretty invested into the course, to be honest with you. I kind of want to finish it. But there's a lot of school to do, this competitive programming thing, and money. Lots of problems or whatever. Today I'm just going to do leak code. And keep on moving on. That's the point of these videos, man. That's the point of the videos. Variable has packages as we ship from port to another within days. ith package. Conveyor belts has a weight of weights I. You stay below the ship packages as a conveyor belt. Order given by the weights may not load with more weight than the maximum weight capacity to ship. Return the least weight capacity to ship that will result in all packages as a conveyor belt being shipped within days. So these are the weights. They're 5 days. Ship CAC is 15. It's a minimum to ship all the packages in 5 days like this. Can't load more weight than the maximum weight capacity to ship. It's the maximum weight capacity to ship. And 3, 6, 10, 15. Return the least weight capacity to ship that result in all packages. Now the cargo must be shipping order givens using a ship capacity 14, splitting the packages into parts like 2, 3. It's not allowed. So we need to determine the size of the ship. The capacity, the weight capacity that is necessary. So we somehow have to determine we could go through and add, the amount of we can go through and keep adding 1 to the capacity until we get through all the packages, right? That's a brute force way, but there's another problem like this that I just recently solved that I think is kind of similar to use binary search, so I don't think this is an efficient solution. So how could binary search be used for this? So the other one, we had to create like an array of all the different potential hours. It was for eating bananas. This when you create a list of all the different capacities that could be used. So, how many different capacities could be used? In an infinite amount, right? But we need a right pointer for binary search, somewhere to end. Otherwise, it's just going to keep continuing. I'm not entirely sure about that. So I know the capacity has to be at least one. So, yeah, I think the capacity could be just the sum of everything in the weights, right? Because suppose we could deliver everything in one day, it would just be the sum of all this happening on the first day. So maybe right should be the sum of weights. Does that even work? Yeah, it does work. So that's what left and right is going to be. So while left is less than or equal to right, we need the current highest weight capacity, basically. 0, we also need to set the result. We're just going to set the result equal to R. We'll change that as we're going through. So we need to loop through the weights for I in weights. We need to set the weight capacity. We need to plus equal it to math.ceiling because we need to round it. You round it up. Oh, we need to find the midpoint of the weights. Yeah, of the capacities. So L plus R 2. We're just going to set this equal to M. Then we need to divide. We need to divide the current weight by the midpoint. So say our capacity is 1, and we divide by, say, 10. I don't even know what this would give because I suck at math. I think it would give 10 or something. Don't know why I'm so bad at this. 0.1. Yeah, this is not going to work because I didn't import math. Yeah. It'll work because I'm not printing out the results. Okay, so yeah, that would equal 1. Then we'd add that to the current capacity. Then we'd do for, because that was 10. Yeah, we would do that for every number, basically. up until, the end. I can't write on this thing. Can't write on a skeleton. I'm not an e-code or any guy. Yeah, I'm not going to try and explain this right now, but so now we have a pretty high weight capacity. We can check if the weight capacity current weight capacity is greater than or equal to M, that means there could be something less. So we need to set R equal to M minus 1 to search the left-hand side of the capacity list. And also we need to set the res equal to the minimum of R and the midpoint value. I think we should do this before. Else we need to set left equal to M plus 1 to search the other side. And we return the result. Okay, this is clearly not it. It's not if it's greater than or equal to M. So clearly this is not even happening. What's the weight capacity? The weight capacity is always less than the midpoint. That's not correct. What are we trying to check the weight capacity against? And we know there could be a lower weight capacity. Okay, I think it's actually backwards. I think a weight capacity is less than mid. Then we need to actually go down, because clearly there is a lower weight capacity in the current value. I think it's actually the opposite. .28 was outputted. Right, that was 20, 30, 40. Well, yeah, we need to don't we need to reset this every time we go through the loop? To check the new weight capacity? No. Why did I submit this? obviously gonna fail. Yeah, obviously. Yeah, one of them is passing somehow. So it was giving 10, it's expected 15. So I think that was actually the bug, not the greater than or equal to. Nope. Yeah, we got 55 again. Weight capacity is always 10. Yeah, weight capacity is 10. It needs to check higher than the midpoint, but the midpoint is 28. That's way too high. God, do you have like a hint or something? Binary search on the answer. We have function possible capacity, which returns true. If we can only, and only if we can do the task in D days. Yeah, it's definitely binary search, but I don't know. I don't know exactly what's going wrong here. Oh yeah, we're not even using the days very well. That's probably a problem. Yeah, we have a maximum amount of days we can use, so. So weight capacity, I think we're putting in a small thing. So the weight capacity was 15. Can be done in 5 days. How do you know that? So maybe we need to find the amount of days it could potentially take, actually, instead of the actual capacity. Yeah, I'm not figuring this out right now, man. I don't know. I don't know what the answer is to this. It's too late for this, man. It's going to. Let's see if he has this question. Yeah, what is his solution here? I'm not. I'll watch the video later. What is the actual solution? Binary search. Yeah, we have to do more things here, don't we? The max of weights and the sum of weights. Why is he using a max of weights there? Oh, because it's at least bound to take at least 1 day based on max weight, right? So like if it's max weight is 10, that is at most going to take 1 day, I think. There's some of the weights. I don't know that it really matters where you start at, but okay, then create a helper function. Can ships in current capacity. 1 cap for W and weight. Current capacity minus W is less than 0. And ships plus equal 1. Ships is greater than days, return false. This is what they're saying with this helper function. Current capacity minus equal W. Left is less than right. Capacity plus 1. I mean, yeah, it's basically binary search. So this is basically checking the current capacity minus the weight is less than 0. And current capacity minus 1 is 14. So that's greater than 0. So that's false, and it's going to just subtract the capacity. I may have to watch this video explaining that. Not exactly sure how it works, but not going to do that on video for lots of reasons. But thank you guys for watching. See you all tomorrow.